Man, don't you love math? Me, I love math. All right, look, we're going to multiply some things today. We're going to multiply polynomials and monomials and binomials and all those nomial things that don't make any sense to you. But we're going to multiply them, and I'm going to show you how to do it. And the first one I want to do is a monomial times a monomial. Okay? So let's look. Number one, 3x squared, y, parentheses around that. Another set, 2x squared, y, and z. Okay, here's what we do. To multiply these things, well, we're just going to multiply the numbers out in front first, those coefficients. So 3 and 2 makes 6. Okay? The next step then is just to look at your variables. Okay, you want to multiply the same variable by the same variable. So what I have is I have an x squared and I have another x squared. Those guys are going to go together, right? So we're going to go ahead and put those together. So x times x, or x squared times x squared, means I'm going to have to add the powers. Okay, what do I mean? Well, if I take x squared and I multiply it by another x squared, I need to take those two exponents and I need to add them together, which is going to make x to the fourth. Okay, then I need to look and see if I have any other variables. Well, I'm going to take a y times another y. Well, these y's have invisible ones as exponents, right? Just like this z here. So y to the 1 times y to the 1 is going to make y to the 2, not y to the 1. Y to the 2, because you have to add the exponents. Okay, last one. I don't have any z's on this first monomial, so that means all I'm going to do is just multiply nothing times z, basically 1, right? So I have a z back. And then I'm done. Okay? It's nice to put x, y, and z in order, though. Okay? Let's look at another one. Number 2. Number 2 is going to be a monomial times a binomial. Let me show you. Let's do 2x squared y cubed z. Okay? It's going to be in parentheses. And we're going to multiply that by 4x y minus 2z. Z is a little crazy looking. All right. It's a binomial because I have this little subtraction symbol in the center. Okay, so we got to be very careful with that. So what we're going to do is we're just going to take this whole thing over here and we're going to distribute it. Okay, just like distributive property. It tells me I'm going to multiply it by this first term, and then I'm going to multiply it by the second term. But what we got to do is we got to do the same thing we did in number 1. Okay, we have to take care of every variable. Okay, one at a time, and blah 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 blah. We got to do that. So what we got to do is 2 times 4 is 8. Okay, I got an x2 and I got an x1 right here. That makes 3 of them, so I have x to the third. I got a y3 and I got 1y over here, which is going to make y to the fourth. I guess the most common mistake is that you forget about this little 1 on top of this y because it just doesn't look like it's there, right? But it's there. And finally, you have no z's here, so I can just put 1z. But I've taken care of the first one. I have to do the second one. And so we're going to do 2 times negative 2, which is negative 4. We're going to do x squared times no x's, so that's x squared. Okay, we're going to take y cubed times no y's, and that's going to be y cubed. And I have a z and a z, so that makes 2 z's, so z squared. What you want to do then is you want to look at these, okay? Do they look like I can combine them and make like terms? No. They all have x, y's, and z's, but they all have different amounts of x, y's, and z's. This one has 3 x's. This one has 2 x's. So we got to be very, very, very careful about that. And so that means we're done. That is simplified, okay? And it is multiplied. All right, we got one more to look at, and it is called a binomial times a binomial. So binomial meaning 2 numbers, okay? 2 terms times 2 terms. So this is number 3. All right, 3x minus 2 times 4x plus 3. All right, so when I do a binomial times a binomial, what I have to do is I have to take and multiply everything together. And to take care of that, there's this little acronym, okay, that all mathematicians use, and it's called FOIL. Well, I also use FOIL when I cook, but FOIL, okay? FOIL means I'm going to take the first term times the first term of the other one. So let me show you. First times the first. It's like distributive property, but I got to distribute everything. 3 times 4 is 12. I have x times x, so that is going to make x squared. I'm done. That's the first. The outers, okay? The outers. The outers are here. These are the outsides, right? Outsides. So outside. 3 times 3 is 9, and then I have an x, so that's 9x. And then I'm done. Inners. That's what I means. Inner. The inner ones need to be multiplied together. So negative 2 times 4 is negative 8x. Be careful with your negatives and positives. And then last is L. The last ones, right? So negative 2 times 3 is negative 6. If you've done FOIL correctly, it should look like a double-chinned man, kind of like me. Get a little double chin. So if you did it right, it's going to look like that. And make sure you do it this way because you're going to make sure you take care of all the multiplication you need to do. Because you got to multiply each part. It's basically distributive property, but you got to make sure you multiply everything. And the FOIL will help you do that. It will take care of that. The last step is you want to look at this thing and you want to say, okay, can I simplify it? Can I combine any like terms? Well, I can. If you notice, these middle terms are like. And they will always be the ones that are very similar to being liked as long as you did the FOIL method. Okay? Notice I got a 12x squared that's going to be by itself, so I can bring it down. Notice I have a negative 6 that's going to be by itself, because I can bring it down. But I have a 9x and I have a negative 8x. Negative 9 and negative 8 make 1. So it makes positive 1x minus 6, and we're done. We got 12x squared plus 1x minus 6. I'm not solving for x here. I'm just simplifying it by multiplying. Okay? Good job. What we've done is we've done monomial times monomial, monomial times binomial, and binomial times binomial. Just in case you cared.